Okay. So check, make sure I'm following along. Okay. So we'll load up the tidyverse. Our libraries, our text library here. Okay. So this will just be some basics. Okay. All right. So here. We'll go to this place. So this is a text file. Show you what it is. It's Macbeth. Okay. So this is, so it's from Project Gutenberg, and then here's it's Macbeth starts off with the three witches, and then you have these different characters. Okay. Okay. So anyway, we'll just we'll take a look. All right. Let me raw text. Oops. Show this again. Okay. So if we load this up. And we click this, you can see the text is all loaded in here. And it looks like a huge mess. Okay. So so what we'll do is we'll go through. And so one issue, I don't know if you guys can see all of this. There's all of these /r/n/r/ns. When the text is loaded, the new line characters get translated into this /r/n business. And that tells the computer basically to start a new line. Okay, one is carriage return and one is new line. Okay. So so here's a few things we can do. So we can take this, all right, and we can do what's called string split. Okay, and we can say split on /r/n. Okay, and when you do that, then it takes the entire text, okay, and every new line becomes a new element in a vector. So you can see each of these things becomes its own line. So we scroll up here, it just keeps going. This electronic version, just each of these things gets its own line here. Okay, and so we can do that. So we can split it into just this big long vector. We can ask so I think, let me just check what the structure of this is. it's so when you do string split, it gives you a list, and this first element of the list is this vector of length 3,194. And so what we're going to do is we're going to just take the first element of that thing, and if we ask what's the structure of this, it's just the single vector. Okay, so we're going to store this into Macbeth. This creates split with the list. First element in the list. 194. Save. Okay, so now Macbeth is just vector where every line, where every element is just a line from the from here. Okay, each of these things. So if we just kind of scroll down, and if I say, okay, what's line, I don't know, 300 through 305. Okay, we can see this is just the text from the play. All right, so we got some lines here. Okay, so what we can do is we can say, you know what, let's search for basically every time somebody is Macbeth is speaking. Okay, all right, so we can do we can take all right, so we can do this work. Okay. Oh, it's pulling Lady Macbeth also. All right, let me just do space Macbeth. Sorry. So these are all of the times where Macbeth begins. The line begins with Macbeth. So space. How often does Macbeth speak? So now Macbeth might have multiple lines. For here example, Banquo starts and keeps speaking, but this would only count as appearing once. So we can say how often does Macbeth speak versus Banquo is 34, Macduff 60, things like that. Okay. So string subset basically searches for this particular particular pattern. Okay. Now, if you just say just this that. Right, and then you can kind of just search for any kind of character, any phrase here, right? You can look for like okay, and anytime there's a go, this will give you this for go, okay, returns matches, say good, or anything like that. Okay, it's case sensitive. You want if you want to make sure it's just the word go, then you can do /b's. Do double/b. Okay. Search for the exact word go. Surround the word. /b. Okay. /b means word boundary. So, so here we've got, basically means the end or the start of a word if you have a /b. So this will work. So you can see that it finds go here, but it also will find go, right? So here it says first which, roundabout, in the cauldron, go. Because an alternative is you can say, well, I'll just put a space before go and a space after go. Okay, because you might try this, but then you won't get matches for something like this. Okay, roundabout, the cauldron, go. All right, so that one doesn't match. So match words, are next to punctuation. Does that kind of make sense? The difference between when you're looking for patterns, /b defines what we call a word boundary. If you want to look for some exact thing, okay, which is better than this, and which is better than that. All right, so this is just basics, searching for words. All right, let's say you wanted to look for lowercase g go or capital go, okay? How do we do that? Well, what you're going to do is you're going to put in square bracket, and you'll put in a capital G or a lowercase g, and an O, okay? So square brackets allow for, searching, or I guess allow for matches any character inside the square bracket. Okay, so this will match capital G or lowercase g. So we'll get capital G O. Oh, okay, and again, because I'm not using any boundaries, this is also going to match lowercase GOOD and things like that. So if we want the word boundary, we'll do //b//b. And so this gives us a few more matches, right? Compare this to where I just had this G. So this will get capital Go, whereas over here, it does not match that, right? It only gets this one. Okay, so these ones don't match. So this will match. There's 25 lines where there's go, and here there's only 18 because all of these only match lowercase g's. And so you can do all kinds of stuff like this as well. So if you can say, well, you know what, I want to match either Macbeth or Macduff. You can use a parentheses. We'll say capture groups, vertical bar, or, okay. So here I can say match Macbeth or Macduff. And so this will match all of Macbeth's lines and Macduff's lines. And I mean, you can also just do so just match Mac B or Mac D, which I think will give us pretty much the same results. So you have that Macbeth or Macduff. And then if I get rid of the two spaces, now we get even more because we have Lady Macbeth and Lady Macduff. Lines, lots of lines getting matched there. Okay, so let's see what else we can search for. All right, so we can use the example. Okay, so this is example from chapter 19, section 2. Okay. What we're going to do is we're going to create a data table with basically characters. All right, so first we're going to create a simple table. Right? And so this is just going to search for Macbeth, and then the / dot just means it has to be Macbeth followed by a dot. Okay, a literal dot, not a meta character. The dot is technically a like a wildcard, but if you put / dot, it will be the actual literal dot. Okay, and then we are going to take this table and we're going to search for, all right, we're going to create a new variable called speaks. And what are we going to do? We're going to run the regular expression. Okay, we're going to take this colon, all right, and we're going to run string detect and run it through our Macbeth vector. Okay, so the mutate command will, so basically what I'm going to do is I'm going to do string detect Macbeth, take each of these things. So the first one we'll do this, and we're going to get trues and falses. Okay. And then over here we do this again. This time with Lady Macbeth. And we're going to get true and falses. Okay. So the mutate command will do the vector false. Okay. When the character speaks. So let's just see this. Okay. So now each of these has a list of length 3,194. Okay. Characters. This is just kind of the result. Okay. Can we figure out what these lines are? Okay, the lines for each of these things. So what we'll do is we're going to take these things, each of these lists of 3,194. Okay. So we'll call this. Okay. So we'll take, and then we'll run the unnest command. Okay. What does that do? It takes the 3,194 and then it kind of it basically does a pivot long. Okay, I've got 4 characters. So now my entire table is, 12,000. It's much, much longer because it's basically pivoting each of these things to be long. Okay. And then nests the data. And then what we'll do here is we're going to create a few new tables, okay? So what we're going to do is we're going to repeat 1 through 3,194 to kind of give us the line, okay? So we're going to repeat 194, and we're going to repeat this 4 times, okay? So when I do that, now I've got which line they speak on, okay? And then we will do okay. And then as numeric speaks will give me a 0 or a 1. And then what we'll do is we'll filter out as far as the lines go. There's a bunch of kind of like nonsense in the beginning, not nonsense, but like the project headers, and at the end there's also kind of just some footnotes at the end. Okay, so we're going to get rid of this stuff. So here we're looking for Macbeth, what they speak, and this is all we have right now. Okay. And what we can do is we can also just kind of filter. Later on, what we'll do is we'll do so we can find out what lines they speak, line 443, and so on and so forth. But not yet, okay? So we'll call this this is our speaker frequency. So we have a bunch of characters of Macbeth and things like that. All right, and what we're going to look for is we're going to look for when the lines when they speak. Okay, so let's plot our speaker frequency data. Take the line. Do that here. And then all right, let's start with this, okay? And we'll do take the color, we'll map the color of our smooth line to the name of the character. Let's just so this is kind of how it starts off looking, which is it's a bit of a mess right now. So we'll add a few options here, okay? Get rid of the error bars, okay? And what do we see? Okay, so looking at the lines, we can see when Lady Macbeth speaks, and we can see when Duncan speaks. Okay, let me change the bandwidth to be a little bit smaller. We'll do method OS. And okay. So here we have Duncan. Duncan gets dies early on, and so he has no lines after here. Okay. And then you have Banquo, who also gets killed. Spoilers here. And we can see kind of where the different amounts of text appear. Okay, so speaking parts. And so this is what we see here. Now we can add additional plots here as far as where the different acts go and things like that, which was done. But here we're basically just taking this speaker frequency, which is just each whether they speak or not. Okay, using the line as again, most of this is either just zeros or ones as far as when they speak. So yeah, this is this is a basic premise here. Okay, you can do some other things, such as just kind of going through and doing like a see if I can count. Yes. Okay, sorry. There's a few more libraries. And so if we look at, you can load up the total number of words here. Um, let me read in the I think I can also do this is a bit of an experiment here. Let me just try this. It's tokens. Yeah, sorry. Type text package. Oh, the lecture review quiz. Do we have any lecture reviewing quiz today? Oh, sorry. I totally forgot about those. Give me a second. I guess I'll give you all three of your answers right now. Okay, your answers are A, E, and B. Go ahead and enter that. A as in apple is your first one. E as in elephant is the second one, and B as in bear will be your third view quiz. Okay, oh, let me try this. That was the issue. Okay, let me try. See if I can.
Yeah, but I can't quite understand if I don't.
Get this. Mess this up. Okay, sorry. Put a column into tokens. I want to just. Okay, here we go. So taking this. Unless the tokens. No count. So column ID not found. Okay. It's the tokens. Okay, here we go. Okay, so here is the top words in Macbeth. Top 100 most commonly used words in Macbeth. So sorry, I had to unless the tokens. Create a data frame out of all of the things, word lines. All right, and so we have 804 instances of the word the, 625 instances of and. So, we got the and of to I, and then Macbeth, it shows up 286 times. No surprise there. Okay, and so we got kind of generic analysis, words that we expect to appear frequently. I do think that the word the, one thing, an analysis of the word in Macbeth, I think they said the word the shows up a little bit too often, but let's see. We have the word count, 20,000 words total. No. Okay, I guess that's approximately correct. So we have the word counts there as far as how often the words show up, and so I think you have different analyses or different possibilities as far as what you can do as far as counting up the words, and so there's a few things you can do to kind of filter out some of the stop words, which would just be like commonly used words, the, and, of, to. Okay, and then you can go through and do an analysis on how often some of these different words appear. Okay, I'll save all of this, and I'll share this file as well. This is just kind of an aside, like a sidetrack as far as some of the different ideas that you can start exploring. I'm not expecting anybody to do any of this for their project, but perhaps if something you found something interesting or something that you want to begin exploring, that's a possibility as well. Okay, we'll end here for today, and continue working on your projects. I will have office hours via Zoom today, and if you have any questions about your project or any help that you have request, feel free to stop by. Also, make sure I think almost all the groups have signed up. I think one group still needs to sign up for a time slot to present, and so please make sure you pick a time slot to do your presentation, and that will be it. Okay, thank you everybody. We'll see you guys later.